Alright guys, today we're going to talk about CPCTC congruence theorem. So that stands for corresponding parts of congruent triangles. Already messing up. Hold on. Feels like I'm right there with you, doesn't it? Of congruent triangles are congruent. Shorthand CPCTC. So what this means is essentially we will continue to prove triangles are congruent by the 5 theorems that we just reviewed: SSS, SAS, ASA, AAS, and HL. But then we're going to take those proofs one step further to prove that certain corresponding parts are congruent. So the way it's going to work is that if I give you 2 triangles, something like this, let's do that this is 90 degrees, and this is 90 degrees, and this was, I don't know, 30, and this was 60, and this was 30, and this was 60, and this side was 5, and this side was 8, and this side was 5, and this side was 8, and I said, hey guys, are the hypotenuse of each of these triangles congruent? And you would say, well, yeah, certainly. And I would say, well, how do you know? And the idea is if we can prove that the triangles are congruent, then that means, of course, all of its corresponding parts are congruent too. So even though nothing is marked here for each of these hypotenuse, we know that they would have to be congruent because we could prove that the 2 triangles are congruent by a variety of those theorems. Okay, so here's how it works. In example 1, it says, given segment AB is congruent to segment DE, angle A is congruent to angle D, and segment AC is congruent to segment DF. Prove. How do you know just the angle C and angle F are congruent to each other too? So before you go to the proof here, I would go ahead and check and make sure that my pictures match my given information, and it does. I see the tick marks for these congruent segments and the arc marks for those congruent angles. So how do we start off every proof? Hopefully you said given information, and that's exactly right. Segment AB is congruent to segment DE. Reason? Given. Then it has another thing of given information, but I would go ahead and make sure I don't repeat something that's already here because they already also put in the proof segment AC is congruent to segment DF, and that's also given. So that I know that this missing given information is that middle piece, which is angle A, is congruent to angle D. So now that I've got all these things written out, well, hopefully you recognize something. They went ahead and already concluded triangle ABC is congruent to triangle DEF by some sort of congruence theorem. So using these 5 from the top, I've got 2 pairs of congruent sides. So this is a side, this is a side, and this is an angle. Well, there's only one theorem that has 2 sides and an angle, and as long as the angle is in between, then we say these triangles are congruent by SAS. So that's where we stopped prior to this topic of CPCTC. Now we're going to take it one step further. Once you've proven that the triangles are congruent, then that also means we can say, well, that must mean angle C has to be congruent to angle F, because if the triangles are congruent, then corresponding parts of congruent triangles are congruent, or in short, CPCTC. Let's look at example 2. Given segment GH is parallel to segment IJ, and angle IGJ is congruent to angle HJG, oh, that's a mouthful, prove the segment IG is congruent to segment HJ. So again, let's go ahead and check our picture, make sure it matches, and it does. GH is parallel to IJ. They have the arrow marks there. So again, we're going to start off our proof with given information. So it says, okay, segment GH is parallel to segment IJ, because it's given. And then the other piece of given information was the angle IGJ and HJG. So that's all given. So once you've got your given information, then we have to figure out, okay, well, what are some other things? Well, the next statement says angle HGI. So let me go ahead and, HGJ. So if we connect the dots, that's angle HGJ. That's this angle right here with 2 marks now, is congruent to angle IJG. So again, if I connect the dots, IJG, that's going to be this angle here. So the proof is claiming those two have to be congruent. And if you look at other things that we know, if these sides here are parallel, and if we have those two parallel lines cut by a transversal, then those angles must be congruent because they are alternate interior angles. So that's what number 3 is going to be. Reason number 3. Those angles are congruent by the alternate interior angles. Let me see what alternate interior angles are. Okay. The next thing, we have to fill in the statement, but they give us that the reason is the reflexive property. So if you remember from the last video, we reviewed that anytime you use the reflexive property, it's to show that a segment is congruent to itself. Well, in this case, it's going to be the segment that these triangles share in the middle, which is going to be GJ is congruent to GJ. And that's by the reflexive property. Then statement 5 starts us off with a congruent statement. It says triangle IGJ is congruent to triangle. Again, before you just name the other triangle, you have to make sure they correspond. So in IGJ, angle I is the angle out in the far corner that doesn't have a congruence mark on it. So we know it must correspond to angle H in the other triangle. And then angle G in this triangle down here has 1 arc mark, so it must correspond to the 1 arc mark in the other triangle, which is J. So H, J, G. Now we have to decide, why are those triangles congruent to each other? Well, let's look at some information that we have. First of all, parallel lines have nothing to do with congruent triangles, so that's not really going to be a side or an angle thing. This one here, 2 angles are congruent, so that's an angle. Here we also have 2 angles, and then here we have a side. So we have 2 angles and a side. But before you go ahead and just put AAS, we have 2 theorems that we could use. We could use AAS or we could use ASA. And remember, it's all about the placement of the side. The side is either going to be between the 2 angles or it's going to be not between them. Well, if you look at this picture, if these are my 2 congruent angles, this is my side between them. Therefore, these triangles are congruent by ASA. So this little tactic here that I've written out of listing what I have is not necessarily going to be the order of the theorem that we're going to use. It's just going to help us to determine which one of these up here can we use. Like, for instance, we can't use SSS because we don't know that the 3 sides are congruent. Okay, so after you've proved that triangles are congruent by ASA, we're going to go one step further. We always finish a proof by whatever it is that we're trying to prove, so that's why I brought this straight here. Segment IG must then be congruent to segment HJ because CPCTC. Corresponding parts of congruent triangles are congruent. For example 3, it says, given segment AB is parallel to segment DE and C is the midpoint of segment AE, prove segment BC is congruent to segment DC. So we're going to start every proof with given information. They already used C as the midpoint of AE, so I'm going to go ahead and write that that's given. And we end every proof with what we're trying to prove. So that's why for the last statement, you just drag over whatever it is that you're trying to prove. Now, we don't know the reason for that just yet, but we do know that that is what we're trying to do. So statement 3 says, angle BAC is congruent to angle DEC. So if we trace those out, angle BAC, this angle here, is congruent to angle DEC, which is this angle here. So again, if we were to extend out, those are parallel lines. Remember, they told us that in given information. So if we extend those parallel lines, and we look at AC as a transversal, we have another pair of alternate interior angles. And we know that if the lines are parallel, then the alternate interior angles must be congruent to each other. Right? Now, statement 4 says segment AC is congruent to segment EC. So AC is congruent to EC. Now, why is that? It has nothing to do with the parallel lines, but if you look back up at your given information, the fact that C is a midpoint of AE means C is exactly between A and E, so that the distance from A to C must be the same from C to E. It divided it right in half. So by claiming those segments are congruent, then that's simply just using the definition of midpoint. Definition of midpoint. Okay. For 5, the reason is vertical angles. So I just need to name what my vertical angles are. So since I've already used 1 arc mark at my vertical angles, I'm going to use 2. And I can't say angle C is congruent to angle C because that's confusing. I'm trying to talk about 2 different angles. So to name this angle here, I either have to call this one ACB or angle BCA. So either one of those. I'll use angle ACB and say angle ACB is congruent to angle. If I'm going to talk about this angle on the right, I either have to call it DCE or ECD, as long as C is in the middle. So I'll call it ECD. As long as C is in the middle, then we are using an appropriate name. So those are congruent by vertical angles. Number 6 says that the triangles are congruent. Triangle ABC is then congruent to triangle DEF. So again, let's look at what we have. Let's go ahead and list out S's and A's on the side to see what we know. Parallel lines, again, don't mean anything. Midpoint, there is no, M in all these theorems, so keep going. Here I have a pair of angles for number 3, so that's an A. For number 4, I have a pair of sides, so that's an S. And then lastly, I have another pair of angles, which is an A. So again, I have 2 angles and a side, but I have to ask myself, is it truly ASA, or could it also be AAS? It depends where the side is. So if you look at your triangle, the side is between the 2 congruent angles here. Therefore, they are congruent by ASA. And then lastly, that must mean segment BC is congruent to segment DC by CPCTC. Okay, on the back side, these are some practice problems. Typically, you do them by yourself, but you're welcome. I won't give it to you for homework. We're just going to go ahead and walk through it together right here, right now. So the first couple, it just wants us to complete the 2-column proofs with the information that it gives us. So for number 1, given these 2 pairs of segments are congruent, prove angle B is congruent to angle D. So again, we start off every proof with our given information, so it's going to be easy. First one's going to be AC is congruent to CE, reason being given. The second reason they already put is given, so we're going to go ahead and write in our other one, which is going to be that segment DC is congruent to segment BC. So that's given. The third thing says angle ACB, so let's trace that out. Angle ACB, this angle, is congruent to angle DCE, to that one. Well, those are congruent to each other because they are vertical. So there we can say vertical angles are congruent. Then from there, it goes ahead and claims that the triangles are congruent. Triangle ABC is congruent to triangle DEF. So again, let's list what we know. Well, the first statement is a pair of congruent sides. The second one is a pair of congruent sides. And the third one's a pair of congruent angles. So you have two sides and an angle. Well, remember, there is no SSA or ASS. So the only option that we have here is SAS with angle that's in the middle. So these triangles are congruent by SAS. Therefore, your proof statement just goes straight down here to number 5. Angle B is congruent to angle D by what we just talked about, CPCTC. It means corresponding parts of those congruent triangles are also congruent. Okay, number 2. Starting off with given information, segment MP is congruent to segment NP, reason being because it's given. The second piece of given information is that these lines are parallel. Remember, that's the symbol for, perpendicular is the upside down T. So those segments are perpendicular because it is given. Then it says OP is congruent to OP. Well, if that's congruent to itself, that is going to be the reflexive property. The reflexive property. And I put 2 tick marks there because they already had 1 tick mark on the triangles already, so I just moved to the next number. Therefore, the triangles are congruent, so let's list what we know. Well, the first one is a pair of segments. The second one is perpendicular. So that doesn't really mean anything quite at first, except that we know perpendicular means 90-degree angles. So that's kind of an angle. And then we have a pair of congruent sides. So right now we kind of have SAS as an option, but the problem is that angle is not between the sides, right? If these are my congruent sides, that angle is over here away from them. So the other option is one that's always going to sneak up on you, is HL. Remember, we can use HL for right triangles that claims that the hypotenuse is congruent to each other and that the pair of legs there in the middle is congruent to each other as well. And then lastly, always drop in your prove statement. That must mean MO is congruent to ON by CPCTC. So those are your 2 column proofs. For the problems at the bottom, it says for each set of triangles below, write a reason, which is just going to be your congruence theorem or postulate. So like the 5, SSS, SAS, etc. to prove triangle congruence. If it's not possible, simply put none. And I'm going to warn you, there are some that might be none. If you have deemed the triangles congruent, then complete the congruence statement for each. Okay, for number 3, if you look at these 2 triangles and we kind of list our important information, we're going to have 2 angles here and the congruent side between them. Therefore, the only option that we have is ASA. And again, the order of the letters matter. So it's triangle TUV must be congruent to triangle WXY. Okay, for your reference as we finish the rest of these, I have the 5 congruence theorems that we're choosing from here once we list out our given information. So, number 4, I already have 2 pairs of congruent sides that are marked on the picture, but I also know by the reflexive property that that third side in the middle is also congruent. Therefore, I know these triangles must be congruent by SSS, and then if I were to name them, triangle DEG would be congruent to triangle FGE. For number 5, if you look at what we've got going on here, we already have a pair of congruent sides marked. And I know that by the reflexive property, this side there is in the middle. So that means I've got 2 sides. But I've got nothing else. It looks like the third pair of sides might be congruent, but we don't know that for sure. There's no theorem or postulate that says we know that, nor do we know anything about the lines being parallel or congruent, angles or anything like that. So all we know is 2 sides. We know nothing else. Therefore, even though they might be, we don't have enough information to conclude that those triangles are congruent to each other. Number 6. The first thing that catches my eye is that I have right triangles. So I know if I have a pair of congruent, if the hypotenuse is congruent, and a pair of legs are congruent, then I'm good to go. Which the hypotenuse isn't congruent as is, but I know if I have two pairs of congruent sides and the angle between them is congruent, then I can still use SAS. So just because it's a right triangle doesn't mean you have to use HL. It just means that you can use HL. This one I still used SAS. So triangle CDE is congruent to triangle FGH. Number 7. Already marked, I have a pair of congruent sides, these two. I have a pair of congruent angles, those. And I also know by vertical angles that this pair of angles in the middle is congruent as well. Now, I don't have an SAA theorem, but if I look at the theorems that have two angles on a side, I do have the AAS theorem, and that's exactly the scenario that I have here. So these triangles are congruent by AAS. Triangle BCE is congruent to triangle DCF. Number 8, if we list out the information that we know, we have a pair of congruent sides that's marked. We have a pair of congruent angles, these both 90-degree angles. And we know that this segment in the middle is congruent to itself. But again, just because I've listed out that information doesn't mean we should jump to the conclusion of SAS, because that angle must be in between the two sides if we can use it. Which, if you notice, the angle is not directly between these two sides, so we can't use SAS. However, it is a scenario in which we have two right triangles, where the hypotenuse which is shared is congruent and a pair of legs is congruent. So then we can say by HL, triangle GJK is congruent to triangle KHG. For number 9, we have these two triangles here. Again, we have two pairs of congruent angles already drawn, but then we know that these angles here in the middle are vertical angles, and they are congruent to each other also. As tempting as this looks, there is no such angle congruent postulate, nor do we know anything about the sides. So as much as they look congruent, we cannot conclude that these triangles are congruent to each other. So for that one, we're just going to have to say none. The last couple, instead of showing us the information drawn on the triangles themselves, they list the information for us. So we're going to have to fill in the blanks, so to speak. So it says segment JN is congruent to segment LM. So let's mark those. Then it says segment NK is congruent to segment MK. And then it says angle N is congruent to angle M. Well, we've got a pair of sides, and a pair of angles. So two sides and an angle. The only one that has that option is SAS. We just have to check that the angle is between the two sides, which it is. So we can say by SSS, triangle JNK is congruent, SAS, triangle JNK is congruent to triangle LMK. And the last one, number 11, it says given SQ and PR bisect each other. Now, at first that doesn't seem like a ton, but you have to remember the word bisect means cuts each other in half. So if they bisect each other, that means, so SQ, so this one here, that means SQ cut PR in half, so that this half is congruent to this half, and then PR cut SQ in half, so that means this segment is congruent to this segment. Okay, we also know, even though it doesn't say it here, that our vertical angles are congruent to each other. So again, we have two pairs of congruent sides, and then we have one pair of congruent angles, two sides and an angle. Again, the only option is SAS. The angle is in between the two sides, so we're going to conclude angle by SAS theorem, triangle SRT is congruent to triangle So there's the practice on all 5 theorems as well as CPCTC.